Lesson 9-4 is on rotations. Rotations, lots to learn about rotations. So we're going to start by looking at the marching band again. Mr. Scott arranges the band in this triangle formation, and then the triangle appears. We need to pay attention to this vocabulary. The triangle appears to rotate clockwise around a point, kind of like a pinwheel. And the center of the rotation is the vertex, which is located at 0, 0. So they start here and then they end up here. And then from here, they go to here. It says this spinning type of transformation is called a rotation. And rotations are defined. That's an important word right there. Rotations are defined by the center of the rotation. As long as the center of rotation is at 0, 0, it's not that big of a deal. But when we start moving the center of rotation around, that's when it can get a little bit tricky. The center of rotation could be part of the figure itself. So like there must be a band member standing at 0, 0. Well, that band member is going to not move from 0, 0 because regardless of how many degrees we rotate, there's still a band member at 0, 0. Now they may not be facing the same direction, but they are standing in the same place, kind of like marching in place. It says it is defined by the center of rotation, which is mapping to itself, and the angle of rotation. So, we already read that. The center of rotation may be part of the figure being rotated, as in the case above, but it does not have to be. You'll see here in a minute, we will take a figure and rotate it, and it will not be at the center of rotation. So before we go any further, I want to talk to you about these points. I want to show you this type of rotation right here. Here is a triangle very similar to what we did. We rotate it. This changes it to 90 degrees. There's the image. This is the pre-image. This is the image. And we move it on around, and there goes the second one. We get it to 270, it plops over there, and then if we go all the way back around, we end up right back where we started. Okay, so there's the rotation. You can kind of see it go fast if you see it. Okay, now what we're going to look at next is a bigger discussion about what this means right here. Functions that describe rotation include, okay, so you understand what they're doing right here. They're telling us about our points that are changing. So it started off being here, and then it ended up being here. So I want to get to you to where you understand this, but I want to do that on another screen. I want to talk to you about clockwise rotation versus counterclockwise rotation. And I think this thing right here, and I'm providing you with the links to all of these things that I'm going to. Okay, I'm going to provide you with the links to these. So you will be able to go and play with these yourself. They should be located somewhere near around the links to the videos. So this is what clockwise looks like. So you can see that this arrow right here is rotating clockwise, and this is counterclockwise. Okay. So to measure, when we use an angle to measure a turn, the direction in which we turn does matter, because a 90-degree angle clockwise is not the same thing as a 90-degree angle counterclockwise. I'll show you right here. See, this one says 90 degrees and it turned the figure toward the right. This one says an angle of 90 degrees and it's turning the figure toward the left. So what is the difference? Okay, well, one's going clockwise and one's going counterclockwise. So you need to be sure and pay very close attention to what Springboard tells you, because we've got two examples. This one is 90 degrees clockwise, and this one is 90 degrees counterclockwise. And I believe this one right here shows us the points. Now, these are not the exact same points that are on your Springboard book. I might can make them the same. Let's see. It was, what was it? 310 and negative 310. Okay, let me see if I can do that. Make it 310 and negative 310. Okay, so now I have them the same place that the Springboard book has. The difference here is that the Springboard book is going counterclockwise. Now I can get over there. I just have to go way over here to 270 degrees, but I can get to the same points that they had. Boy, 270 is hard to get. Okay, so let me go back to Springboard real quick and see. So this says complete the table for the 2 rotations above. So this one's telling me that functions that describe rotations include. So this description right here, let me write on this. The Springboard book is a clockwise rotation of 90 degrees. So let's see if I can write this right here. So we're going to say clockwise. Ooh, I don't like the green. Let's go blue. This is clockwise, a clockwise rotation of 90 degrees. And it says repeat the function twice. So this is a clockwise rotation of 180 degrees. Where does the 180 degrees come from? It comes from the fact that I did 90 degrees twice. So what does this say? If I want to figure out where my new coordinates are going to be, what do? I switch the X and the Y, and then I change the sign for what the X was. So I'm going to switch these. This becomes 10, and I'm going to put the 3 after it, but I'm going to change its sign because I'm going to put the opposite of what the X was. And this one right here, if you switch them 0, 0, you do the opposite, it still stays 0, 0. So that one didn't change. Okay, so that tells you these coordinates right up here. That's these coordinates right here. So 0, 0, 10, 3, and 10, negative 3. And that's what we said, 0, 0, 10, 3, and 10, negative 3. And this one, if we want to get the 180 degree rotation, then what does it say that we do? We keep the X and the Y values the same, in the same place, but we change whatever sign they are. So this positive 3 becomes negative 3, and this positive 10 becomes negative 10. This negative 3 becomes positive 3, and this positive 10 becomes negative 10. And that's the location of, and this one is still at 0, 0, because we got the guy that's marching at the origin, but he's not moving. And that's the location of these points right here. Okay, so that's what those rotations do. In this one right here, it says predict the direction of the arrow after these rotations. So 90 degrees clockwise. So we know clockwise goes like this, the same direction as a clock. Counterclockwise goes like this, the opposite direction of the clock. Okay, so if we're going to do 90 degrees now, 90 switches the X and the Y value. So right here, we should be at 0, 10. We're going to switch those, and it's going to be at 10, 0. So 10, 0 is going to be right here. So I believe the arrow is going to be pointing that way. Okay, 180 degrees. Well, that means we're going to need to rotate this all the way around. Is anybody seeing that 180 degrees kind of makes it look like something else? A reflection over the x-axis, yeah. And 90 degrees counterclockwise. So counterclockwise means we need to go this way. So 90 degrees counterclockwise, my arrow would be right here. Okay. Draw the 3 rotations where your prediction's correct. So yeah, they will be, because I didn't draw the whole thing, but I drew the direction of the arrow. So I said this one would be right, this one would be down, this one would be left. And if you go back over here, here you can even see the points, but I could not get that to get at. I wonder if I could type it in. A little bit more this way. There's 270 exactly. So, yeah, but we're looking at a different picture now. We're looking at the arrow. Okay, so I'll tell you what, we'll just look at the answers and see if we were right. How about that? So yeah, there we were. There's the 90 degrees clockwise, 180 degrees clockwise, 90 degrees counterclockwise. Okay. So describe the rotation that maps figure A onto figure B. So we got to see, remember the rotation, it started off vertical, it ends up horizontal. That's going to be it's probably going to be a 90 degree angle, because if it changes from straight vertical to perfectly horizontal, that's a 90 degree change. And we're looking for, it says hint, first identify the center of rotation. So if the center of rotation is part of your figure, then it's going to be the only piece of this original graph that that doesn't move. Okay, that doesn't move, that stays in the same place. And it looks to me like the only piece that doesn't move is that one right there. So the point, which is what, 1, 0, 1, 0 is on shape A, and 1, 0 is also on shape B. So it looks to me like this is a 90 degree rotation, and they went clockwise. Okay. Describe the rotation. Okay. Now, notice that there's no part of this one that matches or that is still on top of this one. So that means that the center of rotation is going to be right smack dab in the middle. Now, I'm going to show you on another. Actually, you know what I'm going to do? I'm going to stop the video and I'm going to show you another way to find the center of rotation for this one. Okay. So when I come back on the video, I'll be showing you a way to visualize where the center of the rotation is.